Hello and welcome. Welcome to the lecture series titled A Tale of Thought and Technics. Today we're going to be talking about the biosphere, going to be talking about cosmic evolution, about everything that came before what we would know as regular history. So obviously there's a pre-story to everything that's documented, to everything we know about the first rise of human civilization or even the rise of early hominids. And that is the development of the universe as a whole and the emergence of life as a whole on planet Earth. And so when you look at the history of our universe, there's obviously different methods we have to assess it with. We don't have historical records of it. And it is something where we have to focus on the miracles, you could say, the miracles that we can identify about life, about existence. So one miracle or one mystery, you could say, is human consciousness. How did human consciousness arise, or human societies, the complexity of our civilizations? And the other question is, how did life arise? Life being the fundamental mystery that the question of consciousness is rooted in. And then even before that, we have the fundamental question of material existence, of being, the, let's say, fundamental mystery that is the root of the following mysteries. So when we look at it, we have the standard model of physics, or specifically when it comes to cosmological evolution, we have the models for the universes. We've got the model for our universe, also known as the Einstein-Friedmann-Lemaitre universe. Speaking of an event known as the Big Bang, an event that started it all, that created the universe ex nihilo, out of nothing, essentially. And then, after an initial phase of rapid expansion, leading to the state it is now, yet continuing to expand. So this is a universe that is basically in the continuous process of expanding, something that Edwin Hubble discovered. Initially, these theories were trying to establish a kind of order of the universe, something that is eternal. So the idea that the universe had begun and is continuing to unfold bring us back to a kind of more religious attitude at it. For example, the religious attitude that God created the world, that there is a point of creation, a point where everything starts and a point where everything ends, and thus having a clear distinction, a clear asymmetry between the future and the past. That is something that, for example, a cyclical view of history lacks, where eternal creation, maintenance, and destruction is happening in endless cycles again and again. There, before a cycle is always at the same time after a cycle. So looking at the model, we start off with that big bang and then continue with the cosmic inflation, with the rapid expansion of the universe at that time. What is interesting is, obviously, the Big Bang begins with an anomaly. It begins with a mystery itself, and that is the cosmological singularity. One point of infinite density, of infinite weight and energy. And thus the first state of matter has, in a sense, descended from this pure form of energy, this pure form that is, you could say, pure light that only afterwards crystallizes into something like matter. This idea of a being of light, a being of pure unity and a being of pure light that then descends into the material realms. That is something that is very ancient. You have the ancient account of Poimandres in the Corpus Hermeticum, the alleged mystical texts of the Hermeticists, where there is a description of Poimandres beholding the being of light, beholding the eternal being that is the one, that is in this Neoplatonic sense, this eternal being of light, this Godhead that stands at the center, at the apex, and at the beginning of creation, and then descends further into the material spheres down onto our realm. In a similar sense, you can say the point of pure perfection, the point of pure light, of pure infinite density, can be found at the Big Bang, and thus then continuing, descending into further, more crystallized form of matter. Until you reach the point of today, where you had one generation already conglomerating energy into stars, but those stars already dying and leading to fusion of elements into more heavier elements, and thus into what would be the building blocks for planets and for material reality, solid material reality as we know it. And then this second generation of material that has been fusionized in these stars has led to the planets and the moons that we can observe today. Now, this is obviously a theory, an extrapolation of what has been observed. For example, what has been observed by Hubble on the one hand, and what has been observed in the cosmic microwave background on the other hand. So, in that sense, Hubble would have observed the galaxies drifting apart, and the further away the galaxy is, the faster it would be drifting apart. The rate at which the universe is drifting apart is set by the so-called Hubble constant, and this dynamic of galaxies that are further away moving away further from us makes sense if they had all been clustered together in one spot before and have been expanding from that clustered spot since. So on top of that, if you take then a model of the universe in theoretical astrophysics, in specifically models that solve the Einstein equation in general relativity, then what you could predict from that is that there was a point of infinite density, such as you had at the singularity of the Big Bang, that then expanded and got diluted into something that would need to be much, much cooler and much, much lower intensity than it was back then, but it would need to be universal or relatively uniform from everywhere you measure. And that is what is known as the cosmic microwave background that has been observed, which is seen as the essential proof of this theory of the Big Bang and the initial expansion and then crystallization of matter from an initial state of gaseous radiation that you had in the early stars onto the next generation of stars with surrounded planets and more solid matter, more crystallized matter, so you could say. So, as many of you will know, this is the kind of status quo in astrophysics. This is the status quo of science, to look at it this way. And there's nothing wrong with the theory itself. However, it is important to always know that these things don't always have to be taken as gospel, and there are other explanations possible for certain developments in data. Especially as there is a natural limitation as to how far you can look, how far you can see and observe the universe, as entities that are further away than the light, then further away than what would be possible for light to travel in that time, would not be observable by us. So essentially, what is equally possible is that we are the descendant of a local cluster that has been expanding. That is obviously just speculation. There's also cyclical theories. For example, conformal cyclical theories by Roger Penrose that would say that the Big Bang is essentially a an endpoint of a previous universe, an endpoint just scaled at a different level, and we are the descendants of a previous universe that culminated, that climaxed in what we would refer to as our Big Bang. And these kind of cosmic considerations is something we want to talk about today and focus on today. Because, interestingly enough, even though this Big Bang theory is often taken to be a theory that stands in contrast or opposition to a religious idea of creationist cosmology, a religious idea that the world was created by some sort of intelligent entity, it was partially developed by Lemaitre, who was a Catholic priest. And similarly, we're going to be speaking about the early evolution of life and the trajectory, the cosmic trajectory that evolution takes on, that is found in the cosmic root cause of kicking off this cosmic evolution in the first place. And as evolution is also often seen as a contrast to religious explanations, we will be also focusing on another Catholic priest, namely Pierre Teilhard de Chardin, who also had a cyclical view or a kind of symmetric view of our evolution, where the Big Bang represented something known as the alpha point, and the climax, the end point of where our development is leading towards, he would call the omega point, which is again a kind of mirror image of the alpha point. It is again a climax, a kind of peak that we are all evolving towards, which is very compatible with Roger Penrose's notion of this conformal cyclical universe, because there's obviously a kind of asymmetry between the alpha and the omega point. There can only be the one direction, namely going from alpha to omega, but this omega seems to have some sort of similar property, a similar kind of unity with God, a similar convergence into perfection that can be taken as a new beginning, as a new alpha point for the next cycle of the universe. So, essentially, what we will focus on is this early stage of the Earth that will then kick off what Teilhard de Chardin would call the Biosphere, and the Biosphere being the sphere that our planet, the Earth, has developed on top of its purely geological spheres, namely one that has given rise to life itself. So we have the famous geological timeline of Earth. We've got 4 main phases we can speak of. We got the Hadean phase, inspired by Hades, the underworld. It is the phase in which planet Earth was essentially a kind of bubbling bath of chemical explosions and chemical reactions. You could see it as this hellish landscape of lava and fire and smoke. Nothing any living being could survive in. But then you get this really long Archean period. This Archean period that would have gone for about 2 billion years and would be the beginning point of early biochemical reactions, early chemical evolution, the pre-stage that would set the stage to the first living organisms, the first prokaryotic, eukaryotic, the first cellular organisms that would arrive in the next 2 billion years. And essentially then leading to the most famous and the introduction to our age, the Cambrian age, that brought with it the Cambrian explosion, the explosion into many, many species, into many, many forms of life on this planet, of plants, of fungi, and of animals. So, as I've said, this series orients itself along the lines of Arnold Toynbee's work, Mankind and Mother Earth. And Toynbee actually mentions Teilhard de Chardin pretty early on in his chapter on the biosphere. And I'd like to read to you from this quote. The word biosphere was coined by Teilhard de Chardin. It is a new word required by our arrival at a new stage in the progress of our scientific knowledge and our material power. The biosphere is a film of dry land, water, and air enveloping the globe of our planet Earth. It is the sole present habitat, and as far as we can foresee today, also the sole habitat that will ever be accessible for all the species of living beings, including mankind, that are known to us. So the biosphere is also rigidly limited in its volume, and therefore contains only a limited stock of those resources on which the various species of living beings have to draw in order to maintain themselves. Some of these resources are renewable, others are irreplaceable. Any species that overdraws on its renewable resources or exhausts its irreplaceable resources condemns itself to extinction. The number of extinct species that have left traces in the geological record is startlingly great by comparison with the number of those that are still extant. So obviously this contains a bit of a warning, but there is something unique to the means of processing resources that humans have come up with. So many beings, many living species manipulate their environment for their own survival, for their own advantage. But there seems to be something about the human manipulation of their environment that has been inherently relevant to the evolution of human intelligence and consciousness. We will be talking about this in future lectures, but there is something about the co-evolution of our cognitive systems with our technological systems that has made us unique. And there is something to be said that there is a cosmic component to this, that there is a cosmic trajectory towards a further complexification and integration of evolutionary networks. To go on to a little detour, what made me think of this is a quote from a man named Reza Nageristani of his work called the Cyclonopedia, where he speaks of something called the Tellurian Revolution. With the Tellurian Revolution, he means a kind of rebellion, a geological rebellion of planet Earth against the sun. It is the emergence of energy production, energy consumption, and energy processing by planet Earth's own resources, specifically by the human use of fossil fuels, as opposed to the sole reliance on solar power and solar energy that has been dominant thus far. For example, in the photosynthesis of plants and the subsequent consumption of those plants by animals. Nageristani writes, quote, "Trapping the energy of the sun accumulated in organisms by means of lithologic sedimentation, stratification, anaerobic decay, and bacteria in highly stratified sedimentary basins. In this sense, petroleum is a terrestrial replacement of the onastic self-indulgence of the sun or solar capitalism. Earth dismantles the hegemony of the sun or solar capitalism on a subterranean level." So this puts the emergence of human life on Earth into a larger, into a wider context. Seems to be a kind of larger reason, a larger point to the emergence of human civilization and human technology. There seems to be a trajectory that is cosmic in its scale as we become a global, a planetary species. And it is also something that has started a long time ago. So even before we would have had modern civilizations as we know them today. Nagaristani is influenced a lot by Gilles Deleuze, and Gilles Deleuze already speaks of various stages of material development of our world. I can look it up quickly. Yeah, we've got this scheme where... Okay, this is taking me to X. Where you've got the transition from the body of Earth we've got an initial trajectory from the body of Earth, you could say the natural body of Earth, towards the despotic body of initial human high cultures, towards the body of capital money, finally culminating in the full body without organs, the full dissolution of human coherent identity. And this trajectory, in a sense, is not one directional causal from the past to the future, but it's essentially already determined from the future. So what we're dealing with here is a trajectory and understanding of human development that is much larger, much broader, that is part and parcel of the material development of planet Earth. And this brings us to an old question among biologists, and that is the debate between the Gaia principle and the rejection of the Gaia principle. I would contrast them in my own terms as the Gaia principle versus the Uranus principle. And that is the question whether the ecosystem on Earth is an entirely self-regulating system that always balances itself out. In that sense, it itself represents a kind of living entity. That is where the word Gaia is inspired from, namely the Earth goddess from ancient Greece. Or whether there is an Uranus principle, a principle that is represented by the sky god, or potentially Zeus, that is not determined by consistent harmony, but by sudden ruptures, by sudden changes. For example, lightning, in the case of Zeus, is a sudden rupture, a sudden change. If you take the four elements, you got earth and water and air as being part of the consistent harmony of nature, and then you got fire as the sudden, rare but immediate and destructive rupture in the development. And in such a way, we are always wondering about the emergence of these mysteries. For example, did life appear here in a purely continuous, harmonic way, or was there such a thing as a sudden rupture? The idea of the Cambrian explosion would indicate a kind of sudden rupture. It indicates a kind of interplay between the harmonic Gaian forces and the disruptive Uranus forces. And it's the same with the emergence of consciousness and the emergence of human society. Humans have been populating the Earth for well over 300,000 or 400,000 years, yet the sudden spike in population, in technology, in production that we've been seeing is a very, very recent development in comparison, indicating a kind of sudden spike when it comes to cosmic timescales. By the way, if there's any questions, always let me know. The live chat is open for questions. So why are we talking about all this? Trying to get at a deeper understanding of what Desjardins was talking about. Because Desjardins is mentioned even in a history book such as Mankind and Mother Earth by Toynbee, yet the depth of his thinking isn't really grasped at, which does not necessarily mean I fully follow him, nor I would fully agree with this entire worldview, yet it is a very powerful one, and it is also a very influential one, especially in our modern age of liberalism and especially technological transhumanism. And so, as we distinguish between a Gaian and a Uranus force, Desjardins also distinguishes between what he calls a radial and a tangential force. Speaking in pure physical terms, a radial force would mean a force that acts radially, that pulls something towards a center, and a tangential force is something that acts indirectly, tangentially. For example, the magnetic force in an electric field always goes perpendicular to the direction of the electric field, is always exerted perpendicular to the other fields. So it is indirect, it is tangential. However, that's not necessarily what Desjardins meant by it. He wasn't necessarily going by strict theoretical physical measures, but rather a radial force would be a force that integrates, a force that propagates the unification of entities into one to be considered a singular entity. And that singular entity would often then exhibit more degrees of freedom, more ways of configurations and expressing itself. And the radial forces are the forces focused on interaction between two separate entities. So the tangential ones. So the radial ones integrate into one entity, and the tangential ones are about the interaction between two separate entities. And he argues that the complexification of nature is part of the geological process of planet Earth. So essentially, with the integration, with the gravitational integration of a lot of matter into a singular sphere, what you have is a lot of degrees of freedom that need to engage in the cosmic and thermodynamic process of unfolding in higher and higher forms of entropy. Entropy being a state of a measure for a state of disorder, or a maximization of possible states a certain configuration can be in. So, for example, if you have two dice, you roll two dice, and you roll a 7. This has a particular high entropy because if you only know the sum of your dice results, your results, then there are multiple possible configurations that could lead to that result. You could have a 1 and a 6, you could have a 2 and a 5, a 3 and a 4, and so on. Whereas if you roll two dice and the result is a 2, then there's low entropy. You only have one state that this could represent, that is rolling 2 1s. So the second law of thermodynamics essentially claims that there is always an increase. There's always an increase of entropy, an increase of the possible states of configuration. Yet, if all of these potential matter states have been unified and basically wrapped up in the sphere, he concludes that all of these states of complexity, all of these entropic states, all of these maximization of states due to the maximization of degrees of freedom is expanded to the surface level. It's basically pushed out into the surface level. Thus, the maximization of these states is happening on the surface of that planet. And thus, it is only natural that the biosphere, being a sphere of high complexity as opposed to the other layers of planet Earth digging deeper down, it is only natural that it occurs on that surface level. And that this essential trade-off between radial force, where most of the possible entropic states have been neutered by being buried in this huge sphere of matter have been compensated by a high tangential force, a high occurrence of tangential forces right on the surface of that sphere. And this interplay, this kind of tension between a radical strong form of radial forces and a radical strong form of tangential forces is what he would describe as complexity. And in other words, you could say that the interplay between thermodynamic forces, between statistical developments and unfolding of states of matter, and attractive forces like gravity, like electromagnetism, that this interplay is what leads to more complexity, and that complexity essentially approaches a state of maximum entropy, before it stabilizes and leads to a kind of new level of emergence from which a new form of complexity, a new level of complexity can be obtained. And this is all playing out within a frame, and this cosmic frame it is playing out in, that Desjardins describes, is the stage of ultimate simplicity at the omega point and ultimate complexity, ultimate simplicity at the alpha point and ultimate complexity at the omega point, and both of them in a sense being identical, as maximum complexity is so beyond any kind of distinction that it resembles simplicity, only giving a new rescaling factor, so to say, for leveling up onto this new stage. So I understand this is potentially a lot of input, a bit much, a bit complex, but it is nonetheless an important precondition to understanding history on a level, and also the history of our thought and our technologies, which is what this lecture series is focusing on, from a more fundamental level, from a more cosmic level. So the essential evolution of life, the evolution and rise of our consciousness, is embedded in the rise of the biosphere, in the development of planet Earth, which is embedded in the general cosmic unfolding of the universe from this initial point of light, from this initial Big Bang, this initial singularity. And there is this dynamic of essential oneness that splits off into multiplicity. And this multiplicity, however, always engaging in an interplay between interactions between the multiplicity and a tendency to reintegration into oneness between them. And this leads to further complexity and further complexity until culminating in a maximum level of complexity. So for this, I have a quote from The Phenomenon of Man by Teilhard de Chardin on page 27, in which he says, quote, "That which permits the growth of elementary freedoms is essentially the growing synthesis of the molecules they subtend. This synthesis would not take place if the globe as a whole did not enfold within a closed surface the layers of its substance." Right? So you have a certain kind of potential for unfolding of entropic states by the inherent degrees of freedom that matter has. But this matter has clumped together into this spherical body. It has essentially, through its radial forces, engaged into a unity, and to no longer being a multitude of particles unfolding in higher entropy, but being a single entity, that, however, needs to maintain this law of thermodynamics, this law of increasing entropy, and compensates that by exhibiting a higher multitude of entropic states on its surface level, on its surface that is basically represented by the biosphere. And this interplay between these complex degrees of freedoms, these complex entities on the surface level, is balanced off by this intense radial unity of the sphere of the planet as a whole. And so, essentially, what this is serving is as a precursor to what we'll be focusing on in the next lecture, and that will be the focus on the descent of man, on the rise of human consciousness, on human cultures, on humanity as a whole. And in combination with what we spoke about last time, namely the various methodologies and models for history and models for population expansion and geopolitical models, will be serving as a toolkit to further understand the deep unfoldings of our history. And it also allows us to pierce beyond the veil of the superficial level of understanding that we tend to have nowadays, where history becomes a tool of political ideologies that strive to see and identify a kind of never-ending progress, never-ending societal or technological progress, which leads us to further and further freedom and democracy. Yet this blinds us from the fundamental realities that determine the development of history and the development of our thought and our techniques, right? So, to get back at the cycles, the cyclical view in combination with the linear view of how time and history unfolds, we have this idea that there is something that distinguishes future from the past. There is an asymmetry, yet that asymmetry is determined by something physical, by a thermodynamic arrow of time. One where we go from less complexity to more complexity. And this term complexity tends to become so abstract that it's not really clear what is meant by it. And this is important to parallel with something that is intuitively understood by humans in order to really grasp what this means. Otherwise, we're just dealing with theories or papers or particular models that explain a certain thing but don't explain other things. But this whole process needs to be understood in one go and in one holistic process. This process of this initial light, this initial spark that expands, that descends into a multiplicity, that crystallizes into matter, that goes through cycles of generation, through a genealogy of matter, beginning with a kind of pure light, pure luminar form of matter that descends and crystallizes into stellar bodies, and then goes through a second generation where these stellar bodies produce heavier materials and lead to the current stellar bodies surrounded by planets and moons and more heavier materials. And this kind of continuous unfolding and enfolding of material entities, of various beings converging into unity whilst interacting with other separate unit entities. That is this interplay, this tension that characterizes a kind of continuous unfolding of time and a continuous unfolding of novelty and creation. You could say you could say that the Big Bang, the creation, is always ongoing. That initial point, that initial spark, is basically a kind of a retrospective recreation that you grasp whenever you try and approach that unity. yet that action, that particular process, is always ongoing, and this ongoing from the first moment, and this is kind of flowing through the ages, flowing through the eons, flowing through the cycles, and repeating these cycles, but yet leading to newer and newer generations with novel forms of expression. One of which being this kind of awakening, this Tellurian revolution, this awakening of the Earth, the body of Earth, to a independent form of energy production through the biosphere and the biospheric emergence of human consciousness in symbiosis with technology, with the use of fossil fuels, for example. And in this we have this narrow slither in which the complexity is maximized. We have this narrow slither within the solar system that allows for something as planet Earth, and you have this narrow surface on the surface of this globe that has the maximum intensity of this complex unfolding of the planet as a whole. So in a sense, the living world, the living organism, is something the whole planet is engaged in. It is a project by the entire biosphere of the planet. In a similar sense, even our thought, even the development of our ideas and our thoughts of our technologies is something that is part and parcel of this cosmic evolution. In the same way, this development, the complexification of the surface of planet Earth, is part of the cosmic evolution of material bodies in space, in the world, in the cosmos itself. And what this means then for man and the descent of man onto planet Earth and the rise of human civilizations is something we'll be discussing in the next episode. I'll be looking forward to discussing this, and I will see you next time. Thank you very much.